Okay, number 14 on page 865 says this: 2 sine squared x minus 1 equals 0. So remember, we are being asked to find all solutions between 0 and 360. It's important to remember the directions of each problem. On the quiz, I will give you the directions for each problem. So we will solve this normally. We will get sine squared x by itself. That equals 1/2. That part should be a no-brainer. We take the square roots of both sides, so sine x equals plus or minus 1 over rad 2, right? Because the square root of 1 is 1, the square root of 2 is rad 2. But here it's really hard to see what it actually is. So we need to rationalize the denominator in order to figure out what we're really looking for. We are really looking for sine x equals plus or minus rad 2 over 2. Then we go to the unit circle and we say, hey, if I take inverse sine of both sides, where does let's do the positive first. Where does positive rad 2 over 2 exist on the unit circle? Nate? 45 degrees. Where's the other place that it exists? What other place does it exist? It exists at 135 degrees. Okay? Again, where am I pulling my answers from? The unit circle. That's all I'm pulling my answers from. Okay, so if you don't know the unit circle by now, you might want to spend the rest of the period trying to figure out what all these angles are. The next place, I'm trying to look for my negative rad 2 over 2. So that's 225 degrees. Okay, and then the last one I always struggle with, is it 345? 315. That's right, minus 45. 315. Okay? And those are your 4 answers. Now, remember, because I'm solving between 0 and 360, I only need these answers, right? Because it's only one cycle on the unit circle. Okay? All right, so that was it. You know what? Let's try something like 18. 18 is a good problem. Because sine 2x equals cosine x. Because right now, something that's jumping out at me is this sine 2x. I feel that I should use a double angle conversion for this because I want to get things in terms of cosine. I want a cosine in here. Now, unfortunately, sine 2x, the only conversion you have available is 2 sine x cosine x. And that equals cosine x. Now I'm going to subtract cosine x from both sides. So what you get, I'm going to move this over to the side. You get 2 sine x cosine x minus another cosine x equals 0. From here, hopefully it is obvious that you have to factor out a cosine to get 2 sine x minus what? Minus 1 equals 0. From here, you can split this thing apart. You get cosine x equals 0. 2 sine x minus 1 equals 0. This right side term turns into sine x equals 1/2. Okay, so now, again, where do we pull all of our answers from? From the what? Unit circle. So, where does cosine x equal 0 on the unit circle? Where does cosine x equal 0 on the unit circle? Yeah, see. At 90 degrees and at 270 degrees. In other words, pi over 2 and 3 pi over 2, right? Very good. Where does sine x equal 1/2 on the unit circle? Where does that occur? Where does sine x equal 1/2? Nate, what do you got? One's at 30 degrees. What's the other one where it's positive 1/2? Ty, what do you got?
120.
Not 120. Not 120. So 150. 150. And Ty, that's something that people do all the time. They always mix the pi over 3 and the pi over 6 up, but, you know, hopefully it won't happen on the quiz. Okay, so that is 14 and 18. Whoa, that was not supposed to happen. That's because I didn't do this. And this, and this. Cool. All right, so now let's move on to numbers 19 through 23, but I'm going to do the even one, so I'll do, looks like number 20 first. Start off something easy. Now, it says find all solutions when theta is between 0 and 2 pi. So it's exactly like the ones we just did, except our answers are going to be presented in what? radians, right? So it's exactly the same as the last problem, except we're going to be dealing in some radians. So let's see, why don't we do, actually, you know what? 20 is too easy. Let's do number 24. 24. So 2 sine theta, sine squared theta equals negative sine theta. Okay, so hopefully it's obvious. I'm going to add sine theta to both sides. So 2 sine squared theta plus sine theta equals 0. From here, what is the obvious maneuver? Teacher Joseph, what's the obvious maneuver here? To factor out a sine, right? To put the ice cream in the freezer, because that's obvious, right, Teacher Joseph? That's what you told Teacher Stacy. Okay, now we've got sine theta equals 0. 2 sine theta plus 1 equals 0. So here, the right side, I'm going to get sine theta equals negative 1/2. Okay, where are we pulling our answers again? Where are we pulling the answers again? The unit circle. So where does sine theta equal 0? Where does sine theta equal 0? Okay, we're back to radians now. Soph? 0 and pi. Nice job, Soph. The next one, where is sine theta equal negative 1/2? Negative 1/2 on the unit circle in radians. In radians. Max, you got something? Michael, what's up?
11 pi over 6 and 7 pi over 6.
11 pi over 6, and I'll put 7 pi over 6 here. Michael, it doesn't matter on the quiz. If you reverse the two, you're going to get it right. I just like to keep them in numerical order. Okay? Okay, so that is 24. Let's move on. You know what? I want to do one that you guys haven't seen. It's not in the book or anything like that. But let's just say something like, how about sine? How about 3 theta equals rad 2 over 2? Notice how this problem has a frequency change on it, right? The frequency change is that it's 3. It's cycling 3 times faster on the unit circle. So you're going to hit these answers 3 times more often than on a standard one cycle. Okay, so what we do is we say 3 theta equals something and 3 theta equals something else, because remember, we always ended up with about 2 answers, sometimes 3. Where does sine theta equal rad 2 over 2? Max?
Pi over 4.
Pi over 4. And then where else does sine theta equal rad 2 over 2? Where else? Nate? 3 pi over 4. Cool. Now, because there's a frequency change, what do I need to do with this answer? Yemsi? Add 2n pi. Okay? From here, I'm going to divide everything by 3. So I get theta equals pi over 12 plus, I'm going to go ahead and find a common denominator here and put this over 12. So 2n pi over 3 becomes what with a common denominator? Becomes what with a common denominator here? Multiply both top and bottom by 4. Chris? 8n pi over 12. Good. This becomes theta equals 3 pi over 12 plus 8n pi over 12. Okay, now I start making the list. N equals 0. And how many radians am I going to cycle up to? Chris? 24 pi over 12 is my limit. So n equals 0, I get pi over 12. N equals 1. 8 times 1 plus 1 is 9 pi over 12. N equals 2. Looks like 16, 17 pi over 12. N equals 3. 24, 25 pi over 12. However, it has exceeded, so I am done. Max?
So we don't want to reduce it.
You don't waste your time. Just keep it all like this. I'm okay with that. Okay, next one. N equals 0. You get 3 pi over 12. Again, Max, I didn't reduce it just because, just keep everything the same. It's all right. I know you guys know how to reduce fractions. 1 is 8 plus 3, 11 pi over 12. N equals 2. 16, 19 pi, 19 pi over 12, and then n equals 3, 24, 27 pi over 12. However, that's going to exceed our 24 pi over 12 limit, And there you go. Those are our 6 answers for this problem. Okay? All right. So that was a problem that was not on your worksheet, but or the book, but I wanted to show you guys how to do a problem like that anyways. Okay, let's move on. 25 through 32. Solve the equation for all values of x when x is measured in degrees. Okay, we are solving for every value of x in the universe, so when we're all done, you know what, I'm not even going to go there yet. Let's do 26. Okay, problem is different on a couple of levels. 1, the instructions are different. 2, we have to what with this problem? What do we need to do with this problem? Michael, what do you got? We've got to factor this thing. This thing's going to look like this. A sine x goes in both. What 2 numbers multiply to 3 and add to -2? Well, actually, that's kind of a bogus question. What 2 numbers multiply to 3? 3 and 1. What are the symbols going to be in this problem here, Max? -3 plus 1. Nice job. So I get sine x equals 3, sine x equals -1. Which one's the obvious answer? Like ice cream in the fridge, in the freezer. Whoa. Whoa, start calling me Teacher Stacy here. Chris. Oh! Dom. 3. Why? What's the answer there?
It's over 2.
It's over 1, right? Undefined. Now make sure you write undefined. Okay. Now, Chris, I think -1 was an obvious answer. What is it? No. Oh. Maybe I should call you Teacher Stacy. Putting ice cream not in the freezer. Chief.
Well, radians would be 3 pi over 2.
In radians, it's 3 pi over 2. Good. But remember, the instructions say in degrees. So where does
270.
270. Good. Now, here is the question that I was going to ask at the beginning. It's asking you to find all values of x. So what do I need to add at the very end of my answer? Dom.
Plus or minus. Or sorry.
Plus or minus?
360 n.
In this case, you're right, Dom. 360 n because we're dealing in degrees. But if we were in radians, you would have been right. 2n pi. And what else do we need to write at the end of this problem here? Dustin? Where n is equal to any integer. And that's important because you can't just say n can equal anything because n can't equal rad 3. That's not an integer. So it has to be where n equals any integer because that indicates a cycle on the unit circle. Let's do another one. Let's do, how about, we haven't done a tangent one. Let's do 30. Tan squared x minus rad 3 tan x equals 0. Okay, I am going to factor out a tan x. That leaves me with tan x minus rad 3 on the inside. So now I get tan x equals 0, tan x equals rad 3. Now, for speed purposes, this is pi over 3, which is 60 degrees. Plus or minus. This is 0, plus or minus. Now, tangent's a little bit different. What do we add at the very end of tangent? A little different. Devin? 180n, because tangent has a period of 180 degrees or pi radians. And then at the very end, we say where n is equal to any integer. Okay? So that's how you do 30. Yeah, have fun with 27. And 25. Those problems should seem familiar. Okay, so let's take a look at number 34. 34. Okay, the instructions of 33 through 40 say, solve each equation for all values of theta if theta is measured in radians. So, it is the same problem as what we did a few seconds ago, except our measurements are in radians. Okay, so 34. 34 is more difficult on a couple of different levels. Cosine 2 theta plus 3 cosine theta minus 1 equals 0. Okay, Max,
There's an identity.
there's an identity in here. Okay, this cosine 2 theta plus this cosine 1 theta tells me I have to use double angle. Okay, I have to use double angle for that. So what I'm going to do is I'm actually going to just take this step by step. Cosine 2 theta is really cosine squared theta minus sine squared theta, and then plus 3 cosine theta minus 1 equals 0. Okay? And then, notice how I've got cosines and sines flying all over the place. That's bad. So what I'm going to do is I'm going to change sine squared theta into something that has cosine in it. What is that thing that has cosine in it from sine squared? Max?
1 minus cosine.
This is 1 minus cosine squared theta. Now, does it make sense that if we're subtracting sine squared theta, we would be subtracting the whole thing of 1 minus cosine squared theta? Because we're subtracting the whole sine, right? So we've got to subtract the whole conversion. From here, I'm going to distribute my negative. I get negative 1 plus, right, negative times negative, cosine squared theta, and I'm going to bring this cosine squared theta down from the top, plus 3 cosine theta minus 1 equals 0. Cosine squared theta plus cosine squared theta becomes 2 cosine squared theta. Those are gone. Negative 1 minus 1 is negative 2. Plus 3 cosine theta in the middle equals 0. Now, I am ready to factor this thing. I get a 2 cosine theta and a cosine theta. I have a 2 here and a 1 here. I have a plus 3 cosine, so it's going to be plus 2 minus 1. So I get cosine theta equals 1/2. Cosine theta equals negative 2. I feel like we've done this problem before. Anyway, what's the obvious ice cream in the freezer answer here? Teacher Joseph.
1/2.
Okay, that's fine. I'll take 1/2 as the obvious answer. What's the other one? Minus 2, because this is undefined. Yeah, sorry, dude. Okay. Remember, we're solving for all theta when it's measured in radians. So where does cosine equal 1/2 on the unit circle? Dustin. Pi over 3 and 5 pi over 3. And because we're solving for all radians possible, what do I need to add at the very end, Dustin? Plus or minus 2n pi for both, where n is equal to any integer. Let's do another one. Let's do 38. Guys, we can go and skip 37 for now because that's going to require to use a calculator. That's a quadratic formula problem. Okay, you're going to have to use the quadratic formula on that. We might do it a little later. Let's do 38 though. 2 cosine squared theta minus, plus 3 sine theta minus 3 equals 0. Okay. The first instinct is to factor this thing outright. Why can't that happen? Why is that impossible? Chris?
Because one of them's cosine.
Yeah, one of them's cosine, one of them's sine. We got cosines and sines flying all over the place. Now, of the two, sine or cosine squared, which one do we have to convert? Cosine squared. What does cosine squared become? 1 minus sine squared. So now we distribute 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. I'm going to combine these terms here to get, looks like negative 1. I've got a negative 2 sine squared theta plus 3 sine theta, and all that equals 0. I personally like to have the leading coefficient in a factor be positive, so I'm going to multiply everything by negative 1. So I get 2 sine squared theta minus 3 sine theta plus 1 equals 0. I am going to factor this thing out. I have a 2 sine theta and a sine theta What two numbers multiply to 1? 1 and 1. What are the symbols going to be? Chief?
Negative, positive, positive.
Positive, positive?
Or negative.
Negative, negative, right, Chief? Because it goes negative, positive like that, right? Okay, so now we've got, sine theta equals 1/2. Sine theta equals 1. Remember, we're solving for all radians on the unit circle. All values of x in the unit circle in radians. Where is the first instance of of a theta equaling 1/2? Where is the first instance of that happening? Max?
Pi over 6.
Pi over 6. Awesome. Where is the second instance of that happening? Max?
5 pi over 6.
5 pi over 6. Now, what about sine of theta equals 1? Where is that possible? Dustin? Pi over 2. And all of them, because we are solving for all theta, get the plus or minus 2n pi. And from here, that's when you can group them all together and say where n equals any integer. Now, on the quiz, little hint. Each one needs to get the plus or minus 2n pi in this type of answer. Okay, so you can't just group them all and say all of them plus or minus 2n pi. You have to put each one there. They can be grouped where n equals any integer, but each one needs to get an individual plus or minus 2n pi. Yes? Okay. Let's go ahead and stop there.